Bismillah ar-Rahman ar-Rahim. We will continue what we have started. In this problem, he is saying for the AM signal, this is amplitude modulated signal with M of t. M of t is always denoted for the signal. Okay, shown in the figure P4.35. This is the figure, and the mu is 2. Mu is the modulation index. Okay, its symbol is mu, and its value is 2. He's asking for the following: find the amplitude and power of the carrier, and find the sideband power and the power efficiency eta. Okay. For the amplitude, we use the following formula. There's a formula for the modulation index: mu equal mp over a. A is the amplitude. Mp, it is the peak of the signal. Our signal is called m, and the peak is p. So mp is the peak of our signal. So to calculate the amplitude, we can use the following formula: A equal mp divided by mu, which equals mp, the peak here is 10, divided by mu, which is the modulation index, divided by 2. So it will be 5. This is our amplitude, and this is the first part of the first requirement. For the power of the carrier, we can use this formula, which is a square divided by 2. So bc here equals 5 power 2 divided by 2, which equals 25 over 2, which directly equals 12.5 watt. Okay. For part B, he wants to calculate the sideband power and the power efficiency. For the sideband power, we have to use this formula: m of t squared divided by 2. We have to get the power of the signal, then divided by 2. So the power of the signal, if you want to remember its formula, it equals 1 over t naught, which is the period integration from 0 to t naught, m of t with respect to t. So for the period here, which is 10 power negative 3, I have this function. My function is as here, this one and this one. So we can always do a trick in order to avoid getting the equations of this part and getting the equations of this part, which will take much more time. We will say that I will just take the equation for only this part, which is the quarter, only the quarter of what of the signal. This is only the quarter of the signal. Why is it the quarter? Because this is a quarter, this is a quarter, this is a quarter, this is a quarter. So I will take only one quarter. Why do I do this? Just to facilitate the problem and make my life easier by getting only the equation of this part. Okay, so moving to the next part, how to get the equation of this part. I have here 2 points. I will assume my y-axis is here. This is my y-axis and this is my x-axis. Okay, this is x, this is y, and I want to get the equation of this line segment. So this point is 0 and 0. And this point is what? It's 10 power negative 3 over 4. Why is this? Because we have taken the quarter of the period. So it is 10 power negative 3 divided by 4. And what? And this y, which is 10. And 10. Okay, so to get the equation of this line, we can say that, let's get another color. M of t equals 10 minus 0 over 10 power negative 3 over 4 minus 0 multiplied by t. And we don't have any y-intercept, so this will be my function. So m of t will equal 40 over 10 power negative 3 t. This is my function. So I can get to integrate it. This is my function that we have just obtained, 40t over 10 power negative 3. When we get to integrate, I have just forgotten one part. In the integration, we get the square of the function. I'm sorry, we don't use it itself, we use the square of the function. That's why we have gotten here the function and squared it. And we will integrate it not to the period, which is t naught. We will integrate it to the quarter of the period, because we have taken the quarter of the function. As I was just saying, I will take the quarter of the t naught. So I am using t naught over 4. And since my t naught equal 10 power negative 3, so it will be 10 power negative 3 over 4. used here and used here in my part, and I will integrate on this. 1 over 10 power negative 3 power negative 3 divided by 4 is 4 over 10 power negative 3, and I have just taken the constant part 40 power 2 10 power negative 6, since which is equals to 10 power negative 3 power 2, and I will perform my integral here. This can be evaluated by calculator, okay, but I'm here explaining the manual part. The integration of t power 2 is t power 3 divided by 3, and we substitute by the bounds, which is 10 power negative 3 over 4 and 0. Here we substitute by this part and multiply it by what? By this part. Okay, when we substitute in this formula, we will find that the output will be 33.333 and so on. This is the power. Okay, but the sideband power, it says it's m of t power 2 divided by 2. What does this mean? It means that BS equals the power that we have just taken, which is 33.333 divided by 2, which will equal 16.666 and so on, which is approximately equal 16.67. And this will be my sideband power. What? Okay. To get the final part, which is eta, the power efficiency, it will equal what? The sideband power over the carrier power plus the sideband power. So it will equal 16.67 over the carrier power, which is 12.5 plus 16.67, which will equal 0.571, I guess, which is approximately equal 57.1%. If we want to get the efficiency in percentage. And this is the problem. It's an easy one and straightforward one. Just we need to know these concepts and the formula of each one.